Hello everyone, this is your fourth video for Unit 4, Quadratic Functions. What we'll begin to do here is finding our zeros for our quadratic functions and beginning to graph them using other techniques that we'll learn in this video. So, it says find the x-intercepts of y equals x squared minus 4x and then plot them on the Cartesian coordinate system. So if we're finding an x-intercept, that implies that f of x or y equals 0. Because in order for it to be an x-intercept, in order for it to cross this line, our y value here is 0. So the x-intercept has a y coordinate of 0. So what I'm going to do here is let y equals 0 and solve for x. So 0 equals x squared minus 4x. What I can do is I can factor out an x. That implies that 0 equals x times x minus 4. So my two values that make this 0 is either x equals 0 or x minus 4 equals 0. So that means x equals 0 comma 4 is my solution. So if I plug in 0, I get back 0. If I plug in 4, I get back 0. So my x-intercepts are at 0, 0, and 4, 0. So I know that's my x-intercepts. It says graph the axis of symmetry and write the equation of the axis of symmetry. Well, the axis of symmetry is going to be exactly halfway in between these x-intercepts. So that's going to be right here on this line. And the line there is x equals 2. So I know the vertex lies on this axis of symmetry. So let's find the y value when x equals 2. So f of 2 equals 2 squared minus 4 times 2, which is 4 minus 8, which is negative 4. So my vertex occurs at 2, negative 4, which is right here. Plot the vertex, so I plotted it. So here's the vertex, the point 2, negative 4. And here's my x-intercepts. I know this is the axis of symmetry because that happens halfway in between my x-intercepts. Now it says pick two additional values. So let's do negative 1 and 5. So f of negative 1 equals 5, because negative 1 squared is 1, minus 4 times negative 1 is positive 4, 1 plus 4 is 5. F of 5 equals 25 minus 20, which is 5. 1, 2, 3, 4, 5. And here's 4, so here's 5, and then 1, 2, 3, 4, 5. So there's the point 5, 5. And the point negative 1, 5. Now we can actually graph it. Looks something like this. Remember, at the bottom it's rounded. It's not a straight edge down here. It's rounded right here. So there's the graph of my function. Characteristics: the y-intercept is actually 0, 0. It has a minimum. Remember, the vertex value is either a minimum or a maximum. It has a minimum at negative 4. Our domain is still all real numbers, but our range goes from negative 4 to infinity. Since we have a minimum at negative 4, the minimum of our range better be negative 4. Now looking where it increases or decreases, notice on the left-hand side of the axis of symmetry, the function is actually getting smaller, and on the right-hand side of the axis of symmetry, the function is getting bigger. So that means it increases from 2 to infinity, because my axis of symmetry is at 2, and it decreases from negative infinity to 2. This one will have the same type of characteristics. It will go through the 0 point of the origin. There's 0, 0, it'll go through the origin as well. Same with this problem. But let's take a look at this problem. Observation 2. So now this function involves all three terms. We've we've graphed functions that don't have this constant, so it has a 0 factor, right? 0, 0 is a point on that graph, but now we have an equation that has all three terms. The axis of symmetry is always going to have this formula. So therefore, the vertex for x is always going to be negative b over 2a. That's always going to be the point for the vertex. That's always going to be the x value. And of course, the b and a comes directly from this function. So notice if there is no b term, if it's negative 2x squared plus 5, the x value of our vertex is going to be 0. So it's going to be on the y-axis, which makes sense from the previous videos we've looked at. So if this is the x value of the vertex, the y value is just going to be f of that. F of negative b over 2a. This formula will always give you the vertex of a parabola. It's very important to remember. All right? So, let's look at but before we answer the x-intercepts question, because in order to answer the x-intercepts question, we would have to solve this equal to 0. So in order to do that, since we don't know any other method but factoring, we're going to do our sum product table. So our sum is 9 and our product is negative 10. Negative 2 times 5. So give me two numbers that multiply to get 10 and negative 10 and combine to get 9. Well, that's positive 10 and negative 1. Right? So now I'm going to group the negative 1 with the 2, and I'm going to group the 10 with the 5. So this goes negative 2x squared minus x plus 10x plus 5. I'm going to factor by grouping. So negative 2x squared and negative x both have a negative x in common. So we're left with 2x plus 1. And here these values both have a 2 in common. So we're left with I have a 5 in common, excuse me, not a 2. They have a 5 in common, so I'm left with 2x plus 1. So looking at these two terms and factoring out the 2x plus 1 and then negative x plus 5 equals 0. So now my zero factor property states that either this equals 0 or negative x plus 5 equals 0. So this means 2x equals negative 1. This means x equals negative 1/2. So there's one of our x-intercepts, negative 1/2 comma 0. And the other one is negative x equals negative 5, so that implies that x equals 5. So our other one is 5 comma 0. So to get directly in between negative 1/2 and 5, we're going to have a decimal for our vertex. This is where the formula really comes in handy. Our y-intercept is going to be where x is 0. So 0 comma, when I plug in 0 for x, both of those go away and we just get 5. So our vertex is negative b over 2a. So b is 9. So x equals negative 9 over 2 times negative 2. That's a. So we get negative 9 over negative 4, or 9/4. So our x value of our vertex is 9/4, which is 2.25. And then I'm going to plug in 2.25 into this to get my y value. So f of 9/4 equals, that's where we use our calculator. So we have negative 2 negated, times 2.25 squared plus 9 times 2.25, which is what 9/4 is, plus 5 equals 15.125. So notice our leading coefficient is negative, so this graph is going to open down. So now let's plot those 4 points. So negative 1/2 0 is right here. 5, 0, 1, 2, 3, 4, 5, 0 is right there. Y-intercept is 0, 5. So 1, 2, 3, 4, 5. So our vertex is going to be up in here. So it's 2.25. So 1, 2, 2.25. And then 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it's going to be somewhere up here, which doesn't quite fit on the graph. And our graph looks like this. Remember, it's rounded right here. So there's our graph. Our axis of symmetry is x equals 9/4 or 2.25. Here, since our graph opens down, we have a maximum at 15.125. Notice it's increasing on the left-hand side of the axis of symmetry, so it increases from negative infinity to 2.25. And then it decreases from 2.25 to infinity, right? It's decreasing on this side of the axis of symmetry. It's decreasing over here, it's increasing over here. Our domain, once again, is all real numbers. And our range, now we have a maximum value, so the minimum value is negative infinity to 15.125 bracket. So notice this graph doesn't have a b term. So here our vertex, x equals negative b over 2a, is negative 0 over 2, which is just simply 0. So our vertex is going to be on the f of x axis. All right? So our vertex is going to be the point 0, comma, negative 25. Because when I plug in 0 for x, that goes away and I get negative 25. So this is the vertex. And more examples of the same thing. So you have an Explore Intercepts and Symmetry homework, and you have 2 homework problems to turn in where you'll graph them in Excel, copy and paste them into a Word document, and email them to me. Let's go ahead and keep going and looking at an example of an application. So here we have a model rocket. Is launched straight up with an initial velocity of 156 feet per second. So notice that number comes involved right here. That has to do with the initial velocity. Before, the other problems we've done, remember, it didn't have this b term. It just had negative 16t squared plus 40. Now we're involving the b term. So here's the function. So now A says decide where to place the axes and then draw them. So t is a function of time. We don't care about negative time. The smallest value for time we care about is 0. So I'm really just going to graph this in the first quadrant. So this is t, and this axis is h of t. So when t is 0, h of 0 equals 40. So the rocket's 40 feet high before it is launched. So I'm going to let each line be per 10 feet. So each line is 10 feet. So here's 10, 20, 30, 40. So here's where the rocket gets launched from. All right, this is 40. What is the initial height of the rocket? Well, that's h of 0 equals 40. At what time will the rocket hit the ground? So when will our height be 0? So I'm going to set this function equal to 0 and solve for h. So it's negative 16 t squared plus 156 t plus 40 equals 0. Because it asked me at what time. So time is the unknown. The ground, I know the height on the ground is 0. The height is 0 when it's on the ground. So the first thing you do here is look for GCF, a greatest common factor, to pull out of here, which is 4. because it's definitely not 16. This has a 4, that has a 4, and so on. Looks like it might even be 8. 8. Does 8 go into 156? 156 divided by 8 equals? No. So it is 4. So I'm going to factor out a negative 4. Right? So let's pull it out. So I'm going to factor out a negative 4. So we got 4t plus 156 divided by 4. 39 plus 10 equals 0. Now I can divide both sides by negative 4 and basically just get rid of that negative 4. I don't need to consider it when I'm solving for t. So now I need to factor this value, this 4t plus 39t plus 10. So our sum is 39 and our product is 40. Oh, I need to change the signs because I factored out a negative. So this one's positive, this one's negative, and that one's negative. So this is, my sum is negative 39 and my product is negative 40. So that's pretty easy. It's negative 40 times 1. That product gives me negative 40. When I add them together, I get negative 39. So I'm going to write the 1 first. So I get 4t squared plus t minus 40t minus 10 equals 0. So then I'll factor by grouping. Both these I can pull a t out. So it's a t, 4t plus 1. Over here I can pull out a negative 10. And I'm left with 4t plus 1 equals 0. So 4t plus 1 equals 0. 4t plus 1 and t minus 10 equals 0. So this one, when I set this equal to 0, I get a negative value. I get negative 1/4. So we don't care about negative time. This one I do care about. When I set t minus 10 equal to 0, I get t equals 10. So that's the answer to this question. After 10 seconds, this rocket will hit the ground. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I know right here the rocket will hit the ground. So it's going to do something like this. Ooh. Let me do that a little bit better. It's going to do something like this. So there's a vertex right here. What is this point right here? What is the vertex? That's also the maximum height that the rocket reaches. Notice part D asks, what is the vertex? So the t value of the vertex is negative b over 2a, which equals negative 156 over 2 times negative 16. Which equals negative 156 over negative 32. That's good, it's a negative over a negative because we better get a positive value for our answer. So 156 divided by 32 equals 4.875. We'll just call it 4.9 seconds. So at 4.9 seconds, this thing tops out. So 1, 2, 3, 4, 5. And look, I did pretty good. That point looks like it occurs at 4.9. That's the time that the rocket will hit its maximum height. That's not its maximum height. In order to find that, I need to find the height at 4.9 seconds. So I need to find h of 4.875 to be exact. So here we'll go back to our calculator. So we have 16 negated times 4.875 squared plus 156 times 4.875 plus 40. So there it is. Negative 16 times 4.875 squared plus 156 times 4.875 plus 40 equals 420.25 feet. So that's the maximum height that the rocket gets to. So this is 420.25. Notice my scaling isn't exactly correct. As long as I label these values, that's what's important. And this is 10. What is the height of the rocket after 4 seconds? So that's h of 4. Notice it's going to happen back in here, so it better be less than 420. So that's negative 16 times 16, because 16 is 4 squared, plus 156 times 4, plus 40. So let's go 16 negated times 16 plus 156 times 4 plus 40 equals 408, which is less than 420. So now let's talk about domain and range for this problem. The domain, what are all the values that time represents? So the smallest value time gets is 0, and the biggest value time gets is 10. So our domain is only from 0 to 10, including both points. Our range, well, we know our minimum value it attains is 0, and our maximum value is 420.25. Oh, with a bracket, not with a parenthesis. Because if you come back to our graph, the range, even though this point only starts at 40, it actually, the smallest it gets is over there at the when it hits the ground. So our range goes from here all the way up to the maximum value. So our domain is 0 to 10, our range is 0 to 420.25. Same type of stuff here. Maximum height is at the vertex where you find your x values, negative b over 2a. So here x would equal negative b over 2a. So it's negative 1.16 over 2 times negative 0.01, which it's a negative over a negative, which is good. So it becomes positive, 1.16 divided by 0.02. So that'll give me the x value where the vertex happens, and you got to plug it back into the function to get the y value where the vertex happens. And these two problems, the profit loss and the football, are in your homework, so I'm not going to go over them completely. Then we have a blank page, and notice here Applications 2 has 2 questions for you to fill out and turn in to me. Let's look at them real quick. So here's Applications 2. You have a prereq on it. Notice it's only 2 questions. So notice it's talking about the height of a ball is thrown straight up in the air. Here's your function. What is the initial height? At what time will a ball reach a height of 58 feet? So here you're going to set it equal to 58. Let h be 58. You're going to move it over because in order to factor you have to have it equal to 0, and then solve for t. And then notice I want you to graph it. Make sure you label the axes in Excel, copy and paste it to a Word document, and email it to me. 2 different ones. And then here's your profit loss. So that's just like the application from your activity guide. All right? So plenty to do. Let me know if you have any questions. We'll probably be able to finish this unit out with 1, but at most 2 more videos. So our next one will actually start to do the quadratic formula, which the quadratic formula solves for x whenever the function's not factorable. It actually works whenever it is factorable as well. So the quadratic formula will always work to solve for x. Thank you everyone, and have a wonderful day.